wanted from me, basically having a look at my Jira page before going into the blueprints. So for the blocking system, they wanted an NPC that could keep track of the puzzle, which puzzle the player is on, and block certain parts of the map depending on what stage of the game they were in. So if they're on the first puzzle, block to the next room until they've got a certain key or whatever. Let's press the play button, move to the next screen. The hint system, they wanted a NPC that any player could approach, and when they approached it, it would display a speech bubble that you could sort of see from any angle. It was like it was billboarded. And they only wanted that speech bubble visible from the player in range. The other players couldn't see it unless they also approached. If you pressed E, it would give you a hint, and if you asked it again, it would give you a slightly better hint until eventually it gave you just the solution. And each puzzle had its own hints and solutions, so I had to work around that. And if the player who was getting the hint had a teammate nearby, it would also display the speech bubble for them, showing them the hint. And if their teammate was far away, it would do a little subtitle on their screen telling them. And finally, this is probably the most complicated of the three, the subtitle system. Basically, they wanted a manager that they could just throw into a scene, and then in order to make it friendly for people who might be hard of hearing, they would just, whenever they had their voice lines, they would just call a function that would handle the sound for them, and then also play a appropriate subtitle for a appropriate amount of time. Okay, so first off, this is the base class of the NPC system that I set up. Each NPC would inherit from a base class, so this is the base template of the NPC that I put in. As you can see, it's got a basic model, and because the narrative of the game is that these NPCs are ghosts, I put a little glass texture on it, and it gave this very cool sort of transparent, translucent effect. Okay, so very basic stuff here. At the start of the game, you set the base actor to itself, and when the puzzle changes, call the update puzzle counter. So let's go with the start. Set the actor owner. That's relevant for when you step into the collider, it casts it into a different object, and having a reference back to itself is necessary in order for it to be used again. And it's important to have this on the base class so that both NPCs could use this. The puzzle changed event is relevant to the puzzle tracker system that I set up, which isn't on the tasks, but I had to set up as a sort of way of getting these systems to work. To the left, we have the actor owner. That's just a reference to itself. Is player in range? All NPCs have access to this variable. The puzzle tracker, you'd attach the puzzle tracker element to this object, and it would keep track of the number that the puzzle tracker was on. And also has a reference to the speaker, so that's the subtitle system. So each NPC has access to the subtitle system. We're looking at the puzzle entity now. A lot of events here. This is basically to handle replication of certain things. So if you look right down at the bottom, we have an event called update counter broadcast. And what that does is it increments the counter by 1, and then calls on puzzle change, which is at the top, which calls another function, which goes to puzzle change broadcast. And what is sort of going on behind the scenes is, because this is over a network, these custom events are replicating and then casting to the local client. And once it's updated, we go to the puzzle change broadcast. It goes through all the NPCs and calls NPC action, which basically updates the counters on those relative variables that they have, and calls an action on them to basically tell them that the puzzle has changed and to reset any variables or to keep track of the number that they store locally on their local blueprints. To the left, we have some variables such as puzzle counter. That's just the number of number of the puzzle we're on. Puzzle mode maximum. That's to keep track of how many puzzles there are total. NPC is a array that you can assign all of the NPCs to in a scene. So the idea is you'd have an instance of the puzzle entity. You would attach all instances of NPCs to the puzzle entity in that array. And when you do that, it will basically include them in this NPC action call every time the puzzle is changed. The blocker. So this is my blocking system that I came up with. It's inheriting from the NPC base. That's why it's got this model. To the left, we have an array of transforms that's used to store the positions depending on the puzzle count. We have a boolean called deleted, and this is basically when you've completed the last puzzle, it will delete itself and stop calling some of the prime functions of the blocking gate system. The act owner, that's inherited from the NPC base. In players range is inherited. Puzzle tracker is inherited. Yada yada. Alright, let's have a look at the blueprint. NPC action. So that is used for when the puzzle tracker is updated. And what that does is it broadcasts, so it replicates on all of the clients a change in it basically calls the start of this function here called position broadcast. And what that does is it just takes the counter from the puzzle tracker. It finds if it's within the puzzle tracker and it just sets the position based on the array of transforms like I described earlier, so that you could have an array of transforms and a counter, and as you go through that counter it just updates the transform. If you are out of range, it will delete itself and stop calling this function in the future by setting a deleted flag. Okay, so moving on to the more complicated NPC, this is the hinter. The line arrays are for storing voice lines, so you could voice the hints, and then when it plays a function, it will play the sound with it. That's basically all set up, so you can set that up in the inspector. You can also type out hints and put them in this array, and it will do it automatically. It will go from hints to clues to solutions. There is a cooldown counter that's used internally because each array has, well, each hint has a different cooldown modifier, and that's what the cooldown array is for. So this is something interesting. In order to save on variable space, basically what the project manager wanted was a way to store floats for each of hints, clues, and solutions without it taking too much room. And I had the suggestion of, why don't we just use a vector 3? A vector 3, for anyone who doesn't know, is a container of 3 floats, which is very convenient for our solution because we have 3 things that we need to fill, basically. So the X stores the hint duration, the Y stores the clue duration, and the Z stores the solution duration. And that's very well optimized for the Unreal system. So you can ideally just set these all to 7 if you had 7 puzzles and just fill them in. It should be very straightforward. SW context, that is sound wave context. And what that does is it lets you assign a speaker to this blueprint. So if it's default, it will just assume that it's an environment speaking, and it will add those brackets on the end. If you assign a speaker, it will append the speaker's name to the front of the string that is being outputted. So you would probably want to call this like the hinter ghost, or maybe if this character had a name, you'd give it a name and put it there by creating a sound wave speaker. Also worth noting, in the base class of the NPC, you might not have seen it, but there was this invisible cube attached to it. In the blocker, that cube has physics, so you can collide with it and it blocks you. It acts as a collision box, basically. In the Hinter, it acts as a collider box, which means that you don't collide when you hit it, but it generates this overlap event when you enter its area, which is pretty handy. So we have begin overlap for when you enter, and we have end overlap for when you leave, and that does these two functions, which get the player controller and set players in range, enable input, and if you do that, it does a local cast and assigns the start default text. One of these events replicates to both players, or to all players even. One of them only replicates to the local client, and that is important for when one player is entering the area and it only appears for them. The other is used for when you press the E button and it displays for both of them. So it's setting visibility for the billboard, and you couldn't see it in the overview, but basically there is an invisible object above the player's head. It's basically a flat object, the billboard, and a text element attached to it. And by making those visible above the NPC's head, we replicate this speech bubble behavior. If you press the input button, which is the use button, which all the players know, and the cooldown duration is not active at the moment, then you'll call this event called getHint. This next function, getHint, gets the hint from the array. We'll have a look at that in a second because that's a function. It outputs this text output and sets that to what's going to be put on the billboard, and it also changes the stage to the next stage. So first stage is hints, second stage is clues, third stage is solutions. And then it says on output, and when you do on output, it replicates it to local. That's relevant for one player might not get a subtitle because they're looking at it, and one player will because they are. And this will call an event that will use the subtitle system. We'll have a look at that in a second. Okay, so here's what's happening here. We have every second the NPC does this event called update event. And when it does that, it goes here, goes and it sets the text to whatever is relevant to the billboard right now. Then it sets the rotation. So every frame, either player could move. And when they do, we want that rotation to be their position, the NPC's position, minus from each other, and made into a rotation value to set to. So the longer the hint is, it needs to be wider, the billboard basically. So we get the hint, convert it to a string, convert it to an int, to the length of the string, convert that string to a float, and that becomes the new y value of this text box that we have the text on. One more function at the bottom, hiding. Whenever the puzzle is updated, it calls this event. We know that because of the puzzle tracker and the base class, which this overloads. When this does this, it broadcasts reset puzzler, and here's the reset puzzler function. When it does that, it resets the stage to 0, and what that means is when you go to the next puzzle, it will stop giving you solutions and it'll give you hints instead, and then you can do the hint clue solutions thing again. Oh yeah, I forgot to mention. I forgot to do this bit up here. So, if it's bigger than 0, then we decrease it. If it's still bigger than 0 after we've decreased it, then it closes. So basically you can't spam the hint button. You're forced to wait and to come back. There is a function here just called h, That was for debugging, we can ignore that. We're going to focus specifically on sound recast. That was a function that was called below, and this is basically using a switch statement to go through these arrays and output the sound file, if there is one in there, to the subtitle system without a subtitle because there's already one generated by the NPC. In the hinter is a function called getHint. This is that function. We start here, we get the level, the stage, and then we go straight to the switch statement. And what this does is it looks at the stage. If it's 0, we're going to focus just on the hint stuff. So only the hint array, only the length of hint, only the duration of hint, all that stuff. If it's 1, we're going to look at just clues, and if it's 2, we're going to look at just solutions. We have these branch statements here, basically to ask, is it within range? So if it's out of the array index, we don't want there to be an error. We have this simple branch to basically output a string saying you can't do this. This sets the hinter cooldown, and that's important for the speech bubble to close itself after a while and to stop people spamming for hints. Each hint has its own duration. So once that's done, it's just going to output the text as you saw it on in the big function, and also output the next stage. Alright, so this is what the dialog manager looks like. In it we have just this text element. This is a widget that the subtitle and sound manager spawns and then removes once it's completed its duration. You call this when you want to create a subtitle, and when you do, this is what happens. First of all, if you have a sound, you play it. Next, it creates a manager widget. Yeah, so it creates an instance of itself, adds that instance to the viewport, which is the player screen. At the top here, you'll notice that there are these two things. The subtitles should have a way of assigning a speaker, and if there's no speaker, it should indicate that this is an environment sound by putting these two brackets on. So we have a function here for if there is a speaker, and we have a function here for if there is no speaker, and it's just adding the speaker which is on the function to the string and outputting it. And this is just checking if there is a speaker or not. So let's have a look at the other functions. You should notice on this construct that it sets the visibility to hidden. This is because we create the dialog manager multiple times, but only one of them is appeared. This is because in order to access some functions, you need to cast it to a dialog manager to access these events. So that's basically deciding if it goes on the top of the screen or the bottom of the screen. It updates the text. That's here. It just changes that little dialog box we saw on the canvas of the widget and sets it to whatever the input was. That's pretty straightforward. It waits for the duration that you input, and then it disappears itself. Disappear, you can see at the bottom here, it just sets itself to hidden and then removes itself from the parent. What's important here is that there is no delete function for gizmos. You just have to remove them from itself, and then it gets cleaned up in part of the Unreal backend. Okay, so set color. You input color, it uses this function, and it sets the color of the the gizmo text. Set subtitle alignment. This is important because if there are multiple subtitles on screen, which might be the case if there are multiple speakers, we need a way of differentiating or like spacing them out basically. So first of all, we have the switch statement, which is basically saying, do we want it on the top of the screen or do we want it on the bottom of the screen? If there are lots of messages on the screen. If let's say there's 3 on the screen, the offset is like 10. Then the transform, it would be like 30 away from the edge of the screen, and that would basically put it on top of another message that had just been put on the screen. So this is the subtitle and sound manager. We have an array of booleans. So once it's found a place in the register, it will set that register place to false. No other subtitle can use that register while this is being used. This is used later in the function to basically handle the dialogue managing stuff. So the stuff that appears on the screen, we'll come back to that in a bit. After the duration has elapsed, it goes through the loop again. So basically once a subtitle is completed, it frees up their register and we can use that register again. I think keeping blueprints tidy was one of the hardest things on this project. So add to buffer is a function in the subtitle and sound manager that creates a dialogue manager, adds it to the viewport, and calls a function which is in the subtitle manager called create subtitle. The reason we do that is so that it's local to the player, and so we can access the dialogue manager functions that display on the screen, and we can just feed it all of these pins. After we're done, remove it from the parent. It's going to get collected by the garbage collector later. Starting off, we have this custom sound event, which is local to the client. If it has a sound, play the sound at the player's location. The system puts the monologue into this array. It goes through this branch. Okay, so let's break down this statement here. It is comparing the length of the input string and the maximum characters allowed on the screen, which should be a public variable. Basically, if it's more than the max characters, then it has to do all this extra stuff. If it doesn't, then we just go straight to what would happen if there wasn't all this extra dialogue to process, and just outputs all this stuff from here into the add to buffer, which we saw earlier, which was just creating a widget that would call the function to make it appear on the screen if it is longer than the allocated screen space. It calls this function called add to buffer, which is just identical to this, except for some very small differences. So the string is only taking in what can fit on the screen, and it takes a portion of the duration that's allocated to it. And once that duration has elapsed, it recursively calls itself with the remaining text and remaining duration, and it just keeps on going. Play sound. Because we don't assign a sound here, it doesn't play the sound. It sets the monologue to a smaller version of itself. It goes here. Is it still more than screen length? Then okay, we're going to go back in here. We're going to play a percent of the dialogue. Wait, go here, go back here, do it again until eventually you reach the end of the speech bubble, and then it decides, okay, we've reached the end, go here. So all this stuff down here is basically breaking down the duration and the string into separate portions in order for it to handle this stuff recursively. So it gets 2 substrings. One is the first characters up to the maximum characters, and the second is from the maximum characters to the rest of the string. When you get the other half of the string, you call this function called split. It's finding the first spacebar in the string. It says in string here. in that tiny space there's an invisible character, which is a spacebar, and it appends what's left of that spacebar to the start or to the end of the first substring that we had. So if we have a word split, it will basically stick it back on to the end of that string, and it will put it here into the subtitle, the first subtitle that's put out, and it will put the remaining string into the function that's called recursively. That function will keep on being passed forward, and that's how I handled the subtitle. You take the length of the monologue, divide it by the maximum characters. That tells you how many messages need to appear on the screen. You get the duration, you divide it by the amount of messages. That tells you how much time you should allocate for each message. And then I minus 2 from that. When I use this algorithm to calculate the duration of a portioned string, it would leave 0 left for the final call. This minus 2 here, it basically means that the final string that's called will have at least 2 seconds allocated for it to play, which is it's more than enough for a line that is less than 60 characters. This is a function that tells if you are looking at the hinter, and if you are, then it will display the dialogue. If it's not, then you'll just have a subtitle played on your screen. It gets the location of the player, the location of the hinter, minuses them from each other, gets the length, and if that is longer than the distance, then this is true. Basically, if this wasn't here, then if you're looking in a random direction and the hint did go off, it would not display you the subtitle even though you should have a subtitle. So you get the forward vector of this vector and the player's vector, form dot product, times it by -1, and if it's greater than 0.7, that means you are looking at the hinter. And if you're looking at the hinter and you are within range of the hinter, then this condition is true, and we finally get to look at this condition. So you go into the switch statement based on the stage, and it plays custom play sound. Yeah, this is just using the subtitle and sound manager to play a subtitle, and I believe that's it. I'm going to finish editing this. I'm going to include a demonstration of all of these things working at the end of this video. If you have any questions about how any of this stuff worked, just get in contact, that'd be great. Thank you very much for watching. Have a nice day.
Do you not know what happened here, you fools? I know what you're thinking. How am I here? I don't understand either. Something strange happened that fateful night, which has entrapped us here forever. And it has appeared to have entrapped you too. So many terrible, terrible things have happened here. What's horrible is that I don't understand what caused all of this. I woke up like this, with an axe in my back. Perhaps you talk to the others here. They may be able to help you further. It's a bit dark in here. The power is not what it used to be. I will give you some flashlights, but you have to get in the staff room in the back. I suggest that you all take those and make your way to the power generator in the basement.